To understand what radians are, I'm going to start off with the unit circle. And it is called the unit circle because it has the radius of unit length 1. And let's also consider the circumference, which is equal to 2 pi r. So with a radius of 1, the circumference is equal to 2 pi. And that just means that if we start here at this point 1, 0, and we traverse the entire circle back at the point 1, 0 again, that is a distance around the entire circle which is equal to 2 pi. That is the length or arc length as well of the entire circle. Now what I'm going to do is take the entire circumference of 2 pi and I want to divide that into quarters. So to do that, we just divide by 4, which is the same as multiplying by 1 over 4. And this equals pi over 2. So that means from this point of 1, 0 to this point of 0, 1, this arc length in the first quadrant is equal to pi over 2. Now I have inscribed inside this unit circle an angle of 90 degrees, which is represented by this symbol theta. Instead of referring to this angle as 90 degrees, we can alternatively refer to it in terms of radians. So we say that theta is equal to pi over 2 radians. What radians is essentially the arc length created by this angle theta. So we essentially say pi over 2 radians. And what I've done here is I've drawn a new angle called theta 2. And this angle is 45 degrees. But to alternatively refer to this angle instead of degrees, we use the term radians. So to get the radian measure of this length from this black dot to this green point, all we do is take this whole length in the first quadrant and divide it by 2. So we take pi over 2 divided by 2, which is the same thing as multiplying by a half, and we get pi over 4. Pi over 4 radians. And pi over 4 radians is exactly half of pi over 2. Now if you look at pi over 2 radians, this pi over 2, if we do the math on that, we take pi and we divide it by 2, we get the number 1.5708. So 1.5708 radians. That does not give us yet what 1 radian is equal to. So in order to find what 1 radian is equal to, we do the following. We take the circumference of this unit circle, which is 2 pi, and we can also refer to the circumference as the arc length. So the entire arc length of this circle is equal to 2 pi, or also 2 pi radians. So we say that 2 pi radians is equal to 360 degrees because we went around the entire circle. Now we want to solve for 1 radian. So what we do is we divide by 2 pi on both sides. So we get 1 radian is equal to 360 degrees divided by 2 pi. So now when we take the 360 and divide by 2 pi, we get 1 radian is equal to 57.296 degrees. Now we can also find what 1 degree is equal to from this equation that we just found. So to do that, we just divide both sides by 57.296, and it looks like this. We just take 1 radian, divide by 57.296, which is equal to 1 degree, because 57.296 divided by 57.296 is equal to 1. And when we do the math on this, we get 1 degree is equal to 1 divided by the number down here. So that turns out to be 0.01745 radians is equal to 1 degree. So 1 degree is equal to 0.01745 radians. Now I just want to explain one other equation. This equation here is the length of an arc. The S stands for the length of the arc. So if you look at the angle theta 2, it has an arc length of pi over 4, so S is equal to pi over 4. Now what's happening in this equation is we have two factors. We have theta over 2 pi as one factor and 2 pi r as the second factor. These two factors multiply together to give us the arc length S. The theta over 2 pi factor, what that is essentially doing is it is scaling the 2 pi r factor. I'm going to show you what I mean by that. Say that we have theta is equal to 2 pi radians. That means that 2 pi radians is the entire arc length of the circle. So we have 2 pi radians in the numerator divided by 2 pi, and we multiply by 2 pi r, so we have a radius of 1, so we're essentially multiplying by 2 pi, and this is all equal to S. And when we do the math on this, the 2 pi's cancel, and we get S is equal to 2 pi. So you can see that S is equal to 2 pi, which again means that the arc length is equal to 2 pi radians, the entire distance around the circle. Now instead of using 2 pi radians for theta in the numerator for this equation, let's consider using pi over 4. If we were to do all the algebra and cancellations on this equation with pi over 4 as the numerator and an r of 1, we're going to get S is equal to pi over 4. So what I'm trying to show is that we have two factors in this equation. This is one factor and 2 pi r is the second factor. The 2 pi r is essentially the entire circumference. This factor of pi over 4 divided by 2 pi, what that does is essentially, for lack of a better word, it is essentially taking a piece of the entire circumference of 2 pi r. So what we get back is a number, in this case pi over 4. So pi over 4 is a fraction, it is the fraction of 2 pi r. Again, 2 pi r being the entire circumference of the circle. And the reason I used 2 pi in the first example was to show you how this equation works more clearly, where if we think of the 2 pi r again as just the arc length and the circumference of the entire circle, and we take a piece of that circle, so we're essentially, the piece we're taking here is the whole entire thing, because we use theta equal to 2 pi, so we get back the arc length of 2 pi. But down here we use pi over 4, so we essentially get back a piece of the entire arc length of the circle. That piece is the arc length of pi over 4. Now one last thing I want to show relates to this equation again. If we go ahead and do some algebra on this equation, we can go ahead and cancel out the pi's and the 2's, and what we get is S is equal to theta times r. So This is a very familiar equation for arc length. S, the arc length, is equal to the radius of the circle, which is 1, multiplied by theta. So just to take a quick example, S is equal to 1, and here we'll use theta 2. So theta 2 is pi over 4 radians. So pi over 4 radians. And this is equal to 1 times pi over 4, which is equal to pi over 4. So S, the arc length, is equal to pi over 4 radians from this point 1, 0 to this green dot. So that sums up the general idea of radians. Radians is just an alternative measure of angles. So instead of degrees, we use radians. And we do that for convenience throughout various applications of mathematics. And again, as mentioned earlier in the video, radians is just the arc length of a circle that is created from an angle of theta. If you have any questions or comments, please post in the comment section below, and thank you for watching.